welcome to everybody else to our fifth monthly edition of the Master Speaker Series. Today, it's kind of an exciting one because not only do we have a congregant, Dr. Michael Shapiro, who usually does root canals, but he also does astro stuff. Speaking tonight, we had another congregant, the first one, speak. So it's not the first, but it's still impressive. But we also have Rabbi Mike that was so excited about Dr. Shapiro's presentation that he decided to put a Jewish spin on the solar system and the stars and everything up there, so we could kind of get the best of both worlds. So without further ado, I am going to introduce both of you guys, and you guys decide how it's all going to work. Please ask questions through the chat, or that's the easiest way. We always talk about the other things. There's a Q&A thing as well, and Audrey and I will look at it, but the chat is the easiest way to do it. Everybody will see it, and we'll grab those from time to time as they come up. Okay, gentlemen.
Thanks, Gary.
Thanks, Gary. You know, Michael and I spent much time figuring out what would be worthwhile. He showed me some of the slides, and I decided which constellation would be best to show that weren't with my talk tonight. I'm joking, but anyway, you know, in discussing this and Michael sharing with me some of his journey in photography, I said, look, there's a lot of Jewish history involved in this too, and tradition. So I wanted to open up and just give some broad strokes about that, teach a little bit about that, because I think it's some interesting stuff. And then the bulk of the time we can talk about the photography and see the cool things that Michael's created for us. So I'm gonna share with you some text, because I start with the words Mazel Tov or not, you know, and why do I start with Mazel Tov? Most people have no idea that Mazel is actually the Hebrew word for star. And so good stars is that the stars aligned right, and that you will have good fortune in your life. And that's why I said, you know, Shlemiel or Shlemazel, because, well, you know, what we say is Shlemiel is the one who spills his tea. Shlemazel is the one who gets the spilled tea all over his clothes. So Shlemazel is the one without mazel, without stars. The stars aren't there for him. And so why do our tradition link up with stars? Why do we see them as important in tradition? Well, it comes from a lot of the text. So the prophet Isaiah right here, I have this, it references the constellations and the stars. Kochavim is the Hebrew for star, right? Mazel is another Hebrew for star or a star constellation, but also the Chislehem, the constellations. And we see them referenced here in the prophet Isaiah. But what specifically are they talking about there? What constellation? That rabbis in over tradition, they say this is actually Orion. That Kisil is the constellation of Orion. So sort of interesting. We know what Orion is, and we'll be able to see that and talk about that. Jeremiah, another prophet in our tradition, talks about the queen of the heaven. And this part of Jeremiah, he's castigating the people of Israel for turning to false gods, for turning away from Adonai. And for you, do not pray for this people. Do not, and Jeremiah also says that if you don't change your ways, Jerusalem will be destroyed, right? Jerusalem will be ransacked. We'll be carried out of Jerusalem in slavery. Of course, Jeremiah's prophecy comes true in 586 BCE when the Babylonians ransack Jerusalem, destroy the first temple. Nebuchadnezzar leads the people of Israel into slavery, carries us out into slavery. Jeremiah remarkably goes with the people of Israel into slavery. He's carried with us. He's one of ours. But he warns the people of Israel, as for you, do not pray for those people, the ones who have turned their ways. Do not raise a cry of prayer on their behalf. Do not plead with me for me. I will not listen to you. Don't you see what they're doing in the towns of Judah and the streets of Jerusalem? The children gather sticks, the fathers build a fire, the mothers knead dough to make cakes for Queen of Heaven. Anyone know who the Queen of Heaven is? I can't see the chat as I share a screen. I'll tell you. Queen of Heaven, the Queen of Heaven is Venus, the planet Venus. And so we see these words linked up with other texts of Babylonian and Assyrian tradition. And Venus gets connected in Judaism to Queen Esther, but probably because it was from Ishtar, the goddess, the Persian goddess as well. Pivot a little bit here. Why is 7 important in Judaism? There's a link to our discussion tonight. What's the value of 7? since again, I can't, if I stop sharing for a moment, maybe you guys can tell me what you're thinking. If anyone wants to give me the answer, why is 7 important in Judaism? Throw it out there. Tell me what you're thinking, peeps. Come on, give me the chat, Gary Schumann. Yes, Gary, you're correct. You're correct. 7 days of the week, creation story. Thank you, Gary, for that. Yes, the bride, your daughter, will circle around the groom 7 times, that tradition as well. Why else is 7 important? Well, to our talk, in the Talmud, in Jewish law, it says the 7 lamps, okay, 6 days of creation, 7 of Shabbat, mysticism, but also the 7 classical planets. Of course, the moon and the sun are not planets, but in ancient tradition in Judaism, they considered them 2 of the planets, along with Mercury, Venus, Mars, Jupiter, and Saturn, which I think these were the ones that the naked eye could see, and why in a clear sky at night, they would know of these, right? Interesting, I pulled up these words of what the planets are called in Hebrew, which all have a context of how they were seen in Jewish tradition. And I can share this Safari page with everyone if you'd like at the end, so you can see from the idea of the sun being the hot one, realizing what it brings to our life, the moon being the white one, what we see in the sky. So very interesting in that too. But then stars for us in our tradition today, also the astrological connections and what that represents. So is that a part of Judaism? Well, it comes from Greek Roman traditions, which of course our ancestors adopted. Here's a synagogue. Anyone who's been with me to Israel, we go to Tzipori in our partnership region in the north. This is the floor of the synagogue in Tzipori, and it's the signs of the zodiac, the astrological symbols there. You would think this would be a violation of the 2nd commandment, not to, or the 3rd, not to make engraven images of anything, right? And not to have this, but this is in a house of worship. How strange is that? Or in Beit Alpha and Beit Shean, we have this mosaic there of the zodiac again. And the zodiac get linked up with stars and the tribes of Israel, all having significance. So really interesting when you look at the idea of where things come from over time and our idea of why we have these. And so I'll drop this into the chat so you guys can see this too. But and I wanted to see some things that Dr. Shapiro is going to share. But for me, down here, you can see it's all about Abraham. So why is it all about Abraham? And this is the power of stars and seeing stars in the sky and constellations, because understanding what light years are and how long it takes for us to be able to actually see the true star that's in the sky. I remember camping out in the desert 30 years ago in the Negev of Israel, and when you don't have any light pollution, right? When you're literally out in the desert and you can see everything in the sky. In the summertime, there are no clouds whatsoever in Israel. So that's a remarkable thing. And realizing those stars are 4, 5, 6,000 light years away. So they were actually burning when Abraham was walking right where I was. So we have something that's might not be alive today, but it was alive when Abraham was here. Not to take our discussion towards Israel and what's going on today, but the argument that obviously my passion for Israel is strong, and the challenge that I have in how the media is portraying that evil Israel is doing, when I believe Israel is defending itself and has every right to do that. And it takes every, precaution so that civilian lives aren't lost, as opposed to Hamas. But the argument's made like that Israel and the Jews are colonizers and taking over this land. Well, we actually have archaeological evidence of our ancestors being there thousands of years ago, right? Not made up things 2,000, 3,000 years ago. And I find that to be remarkable. And we go back, and Abraham buys land in Hebron in our Bible so that he can bury his wife Sarah there in the caves of Machpelah in Hebron, same area of Hebron that exists today. So now I'm looking up at the sky from the desert, seeing stars that were actually on fire in the time of Abraham's life. And for me, that's a remarkable connection that I feel, because staying in America, my ancestors weren't here 5,000 years ago. Don't know if anyone was 5,000 years ago, right? But in Israel, my ancestors were. And I find that really powerful. And so that's why I love talking about stars in the context of Judaism, right? Astrology became mysticism, became fanciful and farcical, and it's nice little stories. But the science of how a star comes to existence and burns bright and how long it lasts, and that we're seeing something that actually was alive 5,000 years ago when my ancestors, my namesakes, my peoplehood was, that's cool. And that's why I like talking about this. And that's a spiritual part for me that I find so powerful. So with that in mind, I'm going to turn to our friend, Dr. Michael Shapiro, to share some of those pictures of the stars now too.
So that was an awesome lead-in, rabbis. And let me share my screen here. So is that coming through okay? So I'm doing a very informal discussion tonight, but sort of leading on from what Mike was just talking about. And we're going to do a little tour of the heavens, looking at what Abraham saw as best as we can glean, and tying in some of that to the astronomy of ancient Judaism, as well as modern times as well, and all through my own photographic lens. All the photos you're going to see tonight, except for this one, were taken by me. So I didn't take this picture of Abraham standing in the desert.
I did though. I did. Yeah.
So it was all those years ago in the Negev.
Actually, that photo was from Genesis.
There you go. So just to kind of get us in the mood a little bit, this is a photo I took on our Israel family mission, the Temple Shir Shalom family mission back in 2017, 2018, which was my first time in Israel. It was a life-changing, incredible vacation that we got to spend time with Rabbi Mike and met so many friends and family there. And this is outside, of course, the walls of the old temple in Jerusalem. And I can imagine standing there 2,000 years ago, looking up at the sky, and what would we have seen? Now, we don't know exactly what we would have seen, but I can tell you this, that we would have seen dark skies. As Mike was saying, back in that era, everywhere you looked at night was a dark sky. And whether you lived in the desert probably or not, and maybe if you're in the heart of a large city, you would have had some light pollution. But what does a dark sky mean? Well, those of you who haven't had that incredible experience that Mike did living in the camping in the Negev deserts, you have to look really hard to get dark skies like that. And I got a text from my partner Martha saying, we got to get you out in the middle of the ocean. And so unless you've had those experiences, you've really never seen a dark sky. But dark sky means skies so dark they're completely filled with stars, where the band of the Milky Way, our very own galaxy that we live in, which basically spans horizon to horizon over top of us, is so bright and distinct it actually casts shadows on the ground, which is unbelievable. Deep sky objects thousands of light years away that Mike was alluding to can actually be visible with the naked eye. It's so dark that if you had your telescope set up right beside you, unless you had a light, you couldn't see it. That's how dark it is. And so this is an example of a sky like that. This was similar, maybe, not quite as dark though. This is up at the Headlands International Dark Sky Park, right outside of Mackinac City. And my son Jacob and I went up there a couple of years ago for the Perseid meteor shower and had my telescope set up. And as it becomes dusk, you could literally see the Milky Way appear. And it was literally my first time ever seeing that. And so it was like life-changing for me. So I've never experienced those kind of dark skies like Mike has experienced. This is close, so that was about as good as it gets. And this is not a bad image. So on the bottom left here is Mars. Over the horizon here is kind of over the water, and we're seeing a couple of meteors sort of streaking across the night sky. And this is the Milky Way. So that's what Abraham and our ancestors would be seeing pretty much every night, skies like that. Just another view of that same Milky Way. And out here we can see these red areas. Those are nebulae in sort of a wide field. That's a very short exposure. This is like a 45 or 45-second exposure, something like that. And I'll get into that in a little bit. But and that's all showing up very, very quickly because the skies are so dark. It's really capturing really what you can see with the naked eye. In contrast to this, those of us who live in suburbia, this is basically what it looks like when you take a 5-second photograph from my driveway. And where really, if you're in suburbia and you look up in the night sky, unless you have a moonless sky, even then it's not very dark. And typically your sky is the color of a grayish blue. Maybe the brightest stars are visible. You can make out the main constellations like the Big Dipper and Orion, and some of the more well-known ones. Almost everything else is completely hidden. The Milky Way now is completely invisible. You can never see it. In fact, the sky is so bright that once your eyes are totally dark adapted, you could probably read the newspaper at night unaided. That doesn't mean, however, that we can't get some cool pictures even in skies like this. So people always ask me what you need to do to get started with some astrophotography. You don't need to spend thousands of dollars. The cool thing is that even now in 2021, with the latest technology, our iPhone and Android phones actually have really good low light capability. And I haven't tried it, but you can get some interesting dark, some dark sky images. It's not bad. But if you really want to do some serious astrophotography, the basics are a good DSLR camera, something that you can change the lens for different purposes. That's a DSLR, and some kind of a tracking mount. And a tracking mount basically means that you can follow the night sky. The night sky rotates around us, apparently, as the Earth rotates, and it moves pretty quickly. And so the problem when you're shooting stars is that you're shooting a dim target that's really far away, that's moving fast. And so, you want to take a longer image to capture more light, but because the sky is moving, after about 10 to 20 seconds, you'll get star trails, okay, which can be a cool effect, but doesn't make for a great astro image. So this is my astrophotography rig. So this is an 8-inch telescope on a pretty sophisticated tracking mount. And I have a special dedicated astronomy camera that cools down to -20°C to help eliminate noise, and a bunch of other little fancy gizmos here for focusing and following the sky very precisely and capturing the data. But basically, I can carry this whole thing inside and out of the garage and get set up, start and finish in about 8 minutes. So I've got things kind of down pat. So, you don't have to spend a fortune though to kind of get into this hobby. So just some very simple astrophotography. These were taken in Israel, actually from that very same Israel trip that I got to spend with Mike. This was on the left image here. This was up in the Galilee when we were on the kibbutz up in northern Israel, and really dark skies there. Unfortunately, the entire kibbutz was lit up like a Christmas tree, so to speak, because they just had bright lights everywhere. So I kind of went hiking in the back of the kibbutz and found sort of a dark area, got my camera, propped it up on a rock and pointed up the sky and said go. And this is about a 45-second exposure. And so you'll notice that the foreground looks bright because of that long exposure. Oops, I'm going to go back to that one. You talk about Orion, Mike. So this is the constellation Orion right here, which is a winter constellation. And you'd also mentioned the Seven Sisters, the Pleiades, which is right over here. So pretty cool. Over to the right, this image was from our night with Abraham in Abraham's tent, and walking outside out of the tent there after an amazing dinner. Again, took a kind of a cool image looking out over the mountains there, and again, that's Orion up in this corner here. So, Rabbi was talking about some of the important astronomical events in the Bible, and there are many actually that are referencing astronomical events. mainly in the prophets and things of Joel and Ezekiel. And they typically reference things that would be awe-inspiring events for people watching them. A lunar eclipse, a solar eclipse, comets, maybe meteor showers, maybe a meteor strike, like a small meteor hitting or a big meteor hitting. And these might have been tied in with geological events like earthquakes, and then tied in to what was going on around them, of course, because people assume that when they see these kinds of events happening, it must have a deeper meaning. In 2021, of course, we can look at a solar eclipse and understand the physics of what's going on, and it's awe-inspiring, but we understand that that's what it is. Then, of course, they attributed everything to God. And in researching tonight, I was able to find a really incredible article that I sent to Mike earlier as well, that was looking at, from a scientific perspective, the cross-dating of biblical history via singular astronomical and geophysical events over the ancient Near East, and by Ari Ben Menachem, and it was published in the Journal of the Royal Astronomical Society. And what they did was they actually went back and they looked at all of the books of the Old Testament and the Tanakh, and looked at the prophets and chronicles and everything else, and all of the instances in which they believed astronomical events were mentioned, and there were many, and they were able to time those events with actual astronomical things that took place, because we have such good data now. We could back calculate and see when a comet would have come by, when was there a lunar eclipse to the second. They could tell you that on June 14th, 583 BC, during the time of Ezekiel, when he was in this city, he would have seen a lunar eclipse there, and that's what was referenced in that story. Pretty amazing. And so these were actually real events. So with that as a lens now, we're going to show you some of these kind of astronomical events that I photographed. The most incredible, of course, of all is a solar eclipse. And that occurs when the moon moves in front of the sun, which completely blocks out the light. And we have the unbelievable, I suppose, luck, good fortune, whatever you want to say, that the moon is exactly the right shape, exactly the right size, and exactly the right distance from the Earth, that it will completely block out the light of the sun, which is at exactly the right distance from the Earth and exactly the right size. And that's what creates a solar eclipse. A partial eclipse or an annular eclipse is when the moon doesn't quite block out the sunlight. And if it even leaves 1% of the sun uncovered, by the way, you cannot look at it. It can be devastating to your eyesight. But these were important biblical events, and certainly awe-inspiring, and you can imagine fear-inspiring as well. We're often associated with bad omens, perhaps, or that God was unhappy that something terrible was going to happen, or maybe that just something major is going to happen. Eclipses were often described as the sun turning to darkness, and that's exactly what happens. And they're referred to in many cases, including the book of Joel, Zechariah, and Ezekiel. So this is my own personal experience with the solar eclipse. It was incredible, life-changing experience as well. And we had planned with my best friend, Andrew Frank from Ottawa, my brother from Vancouver, my brother Stephen, who I believe is on with us tonight as well. And we planned a trip to go down to Nashville, Tennessee, which was going to be on the totality line and where the total solar eclipse would be visible. It was a band spanning the entire, basically North America, which is one of the first times that has happened in over a century. And Nashville was going to be the longest duration of totality in the country. So we decided we're going to go down there, and I decided to fulfill my lifelong dream of buying my first telescope, and that's what I've got right here. So literally 10 days before the event, I got my telescope, had to quickly figure out how to use it. I had literally not a clue. so we can get that set up down there and maybe create some incredible photographs as well as some memories as well. And so here we are out on the tarmac outside of our hotel. It was literally 100 degrees and like 100% humidity. And so we're outside. Maddie is in her bathing suit so she can go play while we're getting set up. And this is like an hours-long thing because the eclipse takes a long time to kind of, you know, for the moon to move in front of the sun for totality. And had an app on our phone that would count down to the second to tell you when you could take off your solar eclipse glasses, which you can see us all wearing.
Hey, Michael, quick interruption. Somebody asked, when's the next solar eclipse here in this area?
The next eclipse is 2024, and it will be visible in Southeast Michigan. It's in April. Unfortunately, the chance of it being clear skies in April in Michigan is low. So be prepared to get on the road and go somewhere, you know, but it's coming up. So hopefully we'll be able to see one in just a couple of years. So this is what it looks like as the moon's disk is moving over the sun. As this is happening, the temperature is dropping from 100 degrees to 90 degrees to 80 degrees to 70 degrees. And at this point, there is a sense of eeriness, like the hair in the back of your neck goes up. You know something is about to happen. And this is what you see. 2 minutes and 40 seconds of totality. And like nothing you've ever seen. I didn't capture it in the photo. You could see the stars in the background as if it was dark, as if it was darkness there. And the crickets are chirping. It was completely what they would have seen as a biblical awe-inspiring event was awe-inspiring for all of us. You know, most of us were in tears. You know, you can actually see solar prominences or solar flares coming off the side here. The yellow is called the corona, and which only becomes visible really to the naked eye with during a solar eclipse. So this is what they would have seen during these biblical events, and you can imagine how they must have felt, you know, not knowing what was going to happen and then seeing this. Unbelievable. And so here in the bottom left, we see in several instances where they talk about this, but specifically in the book of Joel. And what they said was, the sun shall be turned to darkness and the moon into blood. So that'll lead us into the next topic, which is the moon. After the moon starts to move off of the solar disk, we get what's called the diamond ring effect. And it literally does look like a diamond ring. I'm not sure what carat that would be, but it's big. And so here's the moon. Of course, you know, we never get tired of looking at the moon, and humans, for as long as humans could look at anything, have looked to the moon. It's, you know, it's always facing us because it's tidally locked to the Earth. It rotates around the Earth at the same rate, and it itself doesn't rotate. Okay, so it's an orbit around the Earth, but we always see the same side facing towards us. It really never changes, or very, very, very little. And because of this, we have a very predictable series of lunar phases. And of course, that's what allowed us to form a lunar calendar. Judaism is based on a lunar calendar as opposed to a solar calendar. And a lunar day, a lunar month is about 29 and a half days, a little bit shorter than a typical solar month. And so a lunar year is about 255 days. So about 10 short of a solar year. So we have every couple of years, and Rabbi, you can remind me of this, but I believe every few years we have to add an extra month into the Jewish calendar.
Right, every 4, 7, 9. It's a weird formula. And this is actually an amazing thing because you think about understanding the lunar calendar, and that in the Talmudic times, like Yochanan ben Zakkai was the one who mastered it, one of the great rabbis in the 2nd century, and figured out how to count time this way. Our calendar was already working, but you know, what's amazing is that we get a whole extra leap month as opposed, you know, our Gregorian calendar is 365 and a quarter days long. So we add February 29th every 4 years to make that up, right? our lunar calendar has to add a whole extra month. And they do that every on a leap year, every few years, like we said. And it's really remarkable. They calculated this thousands of years ago to figure out how it works. And as opposed to Islam, who follows the lunar calendar but doesn't justify their calendar, so suddenly you have fall harvest holidays happening in the springtime. So our Rosh Hashanah may be on the evening of Labor Day this year, but it's still on the 1st of Tishrei. It's still the same month.
Yeah. So I mean, it's pretty incredible that they did that, and that they mastered the calendar, and it allowed them to predict things, like you said, the harvest, when to plant. They could accurately calculate, when they needed to do things. Interestingly, most of us know that many of the moons, the full moons, are named. For example, a harvest moon, and they come up with these wild names, which, by the way, mean absolutely nothing. So people always ask, like, what does that mean? Does it mean it's going to be that certain color? No, it does not. The full moon really never changes, other than the fact that occasionally we get what's called a super moon. And a super moon means that the moon is actually a little bit closer to the Earth. And so it does visually look bigger because it is a little bit closer. When we look at the moon, visually, it looks like a bright white object because the sunlight is reflecting off of it so brightly. In fact, it's hard to look at the moon through a telescope. It's blinding almost. So this is what the moon looks like in color. And this is not false color. This is not color I added to it. This is just simply increasing the saturation of the image that's already there. And if you think about it, the moon is rock. Rock here on Earth isn't opaque white. And it only looks opaque white because you've got this intense bright lights shining on it. And so you've got all these different elements and minerals on the moon, just like we do here on Earth, iron and various other things as well. And so that's what gives us this color. But that's really what the moon looks like. There's this bright blue area over here. That I don't know what it is. And there are conspiracy theories that NASA's got a fusion reactor set up there. I don't think so, but maybe it's true. And we can get some occasional cool images with the moon. On the upper left-hand corner, that's Mars. So this was last year's conjunction with Mars. And that's just kind of a little bit of a close-up there. And this, of course, is not a full moon. And when there's not a full moon, we can get much more detail at what's called the terminator, which is where the dark and light areas meet, because that contrast allows you to see much more detail. So that brings us to a lunar eclipse. And this was the super blood wolf moon of January 2019. It was like the coldest night in Michigan that I have experienced in years. It was like -30. My telescope stopped working. It was so cold. I couldn't feel my hands, and somehow managed to get some images. But this is what a total lunar eclipse looks like. Now, why does a total lunar eclipse look red? Because when the Earth passes in front of the sun, it's that we're blocking the sunlight, except that it doesn't block all of it. And the light in the red wavelength bends around the Earth and is what is the only part that actually hits the moon. Everything else is sort of bounced away. And so that's why it looks red as opposed to its normal color or blue or green or something else. And of course, back again to this quote here, the sun shall be turned into the darkness and the moon into blood. And that's what it would have looked like to them, that literally the moon had turned to blood. Again, an awe-inspiring event. The difference between, a solar eclipse and a lunar eclipse is that, unlike a solar eclipse, which lasts for just maybe a few seconds or a minute or two, lunar eclipses can be a little bit longer. And every once in a while, you get a lucky shot. This was a lucky shot, and didn't plan that. Took a bunch of photos and just looked at my camera and saw that in there. And so I did not Photoshop that in. That is a plane crossing through the moon. You can see its engines and contrails coming right off of there. That was a lucky shot. So now we'll talk about the planets. And Mike was talking about, the importance of the planets in Judaism and astrology as well. they were recognized by the ancients as being something not the same as the stars because they moved differently. They moved at a different rate because the planets being in our own solar system are orbiting the sun. Different planets orbit at different rates. Depending upon where they are, they follow a very predictable pattern across what's called the ecliptic. The planets became associated with the gods because they recognized they were different. They were something special with them, and so they did take a very important aspect as well. In terms of capturing them photographically, they require video to capture photographic detail, as opposed to long exposure photography, because if you look at a planet, they're super bright. The best example, of course, is Venus. Venus is unbelievably bright. It's the second, next to the moon, it's the brightest thing in the night sky. So imaging Venus is actually really hard. I don't have any good images of Venus to show you tonight, unfortunately. But you have to capture video and put the images, the individual frames of the video together to get some good images. So we're going to start with the best, or let me just say the grandest planet of them all. I don't know if it's the best, but it's Jupiter and the Jovian moons. And at any one given time, you can see usually a maximum of 4 Jovian moons: Europa, Io, Callisto, and Ganymede. By the way, Ganymede is even bigger than Mercury. That's how big those moons are. So they're the biggest object in the solar system other than the main planets. So this is a nice capture of Jupiter. I was happy to get the cloud bands here, the color, and of course this is the infamous red spot, the great red spot, which is 3 Earth diameters wide. It's a storm that has existed for hundreds of years. So may not be quite as big, but I think it's even more beautiful. This is, of course, Saturn. And these are the Saturnian rings, which are composed of billions and billions of particles of dust grains and, somewhat bigger, maybe rocks, etc., in multiple different rings. I was very pleased to get this, and where you can actually capture the division between the rings, and which is called the Cassini division. And Saturn has some incredible moons as well. Titan is often regarded as one of the best. This was from last year, Mars at opposition. Opposition means it was actually at its closest approach to Earth for the next many decades, and it was visually significant. It was like twice as big as I've seen Mars before, and finally was able to get some decent imaging out of Mars. My telescope's not really geared for imaging the small planets as well as a bigger telescope is. And so I was pretty pleased with that. You're able to see some surface details here, the polar caps as well. Mars does have polarized caps, just like the Earth does. Now, Rabbi also mentioned, the alignment of the stars and the planets, and its impact in astrology and the astronomical lore, and especially in astrology. The alignment of the stars or of astronomical objects, which is called conjunctions, is very important. There's this belief that when the planets line up in a certain way, certain things are going to happen. I had a patient literally tell me that right now it's going to be the age of something or other, so it's better to not have a root canal when you're in that astrological phase. I said, okay, that's not a problem. So there are people that still believe these things, but if you think about it, the alignment is strictly a visual phenomenon. It has no bearing really on anything astronomical or physical, for that matter. But this year was a cool conjunction from a photographic standpoint, in that it was the great conjunction of Jupiter and Saturn, which the last time this happened was in the Dark Ages. And there's some conjecture that maybe this is what was believed to be the Christmas star. I think that it was more of like Jupiter and the massive star Rigel together, but the conjunction in this case was so the alignment and the close alignment of Jupiter and Saturn was so close that they looked like one object, unless you use a telescope, which I did. And so So I was one of the few people from Michigan to get a good quality image of the conjunction. I had like 12-minute window between the trees to get this image. And this is what it looks like through a telescope to see Saturn and Jupiter and the Jovian moons. You cannot see 5 Jovian moons. And this little guy here is a star that happened to be just along for the ride. So comets are another one of these astronomical phenomena that are really important. And we see them, we know about them now. We can actually discover them and follow them. NASA's actually sent, probes to them. And so we understand them much better. But in the ancient times, these were things that they had no idea what they were looking at. So what is a comet? It's a giant ball of ice and dust, basically. And they come from very, very, very far out in the solar system, sort of beyond the planets. And they circle in very, very long orbits, some of which can be thousands of years, as opposed to 1 year for the Earth to go around the sun. Some of these comets could take thousands of years to go around the sun. But they have a repeatable orbit. And as they get a little bit closer, the sun's energy blasts off massive amounts of dust and water crystals, and they form these tails that literally are millions of kilometers long. Some of which can be visible to the naked eye. This was the comet Atlas that I imaged last year, and got lucky in that it was passing by 2 of our neighboring galaxies, M81 Bode's Nebula and M82 called the Cigar Galaxy. So I got this cool image here, and this was one of the first times I ever shot a galaxy. Galaxies, of course, are very bright, and static. The comet is pretty dim and fast moving. So to capture this and stack the data was a whole. You could do a lecture just on how to photograph a comet, but I was very pleased with that. Last summer was the first time since Comet Hale-Bopp in '96 that we had the comet was visible to the naked eye. This, again, is something that would have been of a biblical proportion. And this is Comet Neowise. This comet was only discovered in March of 2020. NASA scientists did not know that this existed. It was discovered and very quickly became massively bright so that it was visible to the naked eye. Incredible. And so we go here to look at what would the ancients have thought. And so there's this minor prophet Habakkuk, who I've never heard of, Rabbi. Maybe you have. I'm assuming you have. But in his, you have. That's good. Thank you. That was a test, by the way. And he wrote, and in his brightness was the light, was as the light. He had horns coming out of his hand. The sun and the moon stood still in their habituation and in their habitation. At the length of thine arrows they went, and at the shining of thy glittering spear. And so all these references to the light horns, the light arrow, the glittering spear, most scientists believe that they were talking about a comet. And sure enough, right at this time, they were able to figure out that Comet Halley made its appearance in 616 July BC, and that would have been at the time of the prophet's writing, is what they believe. So they probably saw something that looked just like this. So this was an image that I took. This was just at the Robert H. Long Nature Preserve on 14 Mile and M5, right off the M5 there. And this was right at dawn. And I needed a clear view of the horizon to the north, and I was able to get this image. And it looks like it's a plane. If you didn't know what you're looking at, you would think this was a plane. These are the contrails of the plane. This is the sun coming up. This is how bright this is. And astounding. I couldn't believe it. I mean, it looked fake. It looked like it was pasted on the sky. So you can imagine again, 3,000 years ago, what people would have thought when they saw this. And of course, in dark, not light polluted skies, it would have been unbelievable. This is what that same comet looks like when you photograph it through a telescope. So as one of the few people, to my knowledge, in the world that used my particular telescope to image the comet Neowise, and what you can see is this bright glowing orb in the center. That's the nucleus of the comet, and blasting off of that bright orb are these massive dust trails, which is the brown, and this bright massive ion trail, which you can see is like spiraling lines coming off of the comet, and that's an ion trail coming off.
Michael, can you talk about the coloration? Mel asked a couple slides back why Mars appeared red. In this picture, you got some of the trail is red, some of it's like a blue or a green. Can you speak to that?
Well, Mars looks red because of the color of the rock on Mars, and which is heavy in iron. And so that's why, the planet itself looks red. And, in this case, I believe that the blue here, is going to be a lot of water vapor and other ions in there as well. I couldn't tell you what makes up the dust in particular, but I'm sure I could research that for you and get back to you, as far as what causes that particular color. But most of the comets will tend to have sort of a greenish nucleus like this. And I've read some science as to why they think that looks like that, there's people actually look at these things and say, why does it make that color? So it's a good question. I can't answer that specifically, but I hope that helps. And again, looking back at that quote, is the light horns, the arrows, the glittering spear, you can envision that, of course, coming off of this.
Hey, Dr. Shapiro, another question. This one, a very important one, because it's from Mavis. She wants to know why Saturn is purple.
Why Saturn is purple?
Yes.
So Saturn's not really purple. It's probably just the I don't know if that looked like my image was purple, but probably not the best color, but the big planets like Jupiter and Saturn are all made up of gas as opposed to rock. And those gases are swirling at thousands of miles an hour in some cases. And you have all kinds of crazy color formations happening. And if you look at Saturn today versus next week, it might look different. And definitely if you look at Jupiter today versus next week, it's going to look very different. The cloud formations change a lot. So lots of different colors there. Yeah, it's a great question, Mavis. So now we've talked about all these things that happen that would have been really important in the biblical sense from things that are inside our own solar system. These are near Earth objects, right? Now we're going to talk about some deep sky objects. And these are nebulae, galaxies, and star clusters. They're very far away, very, very far away. And as Rabbi Mike had indicated, they're hundreds or thousands or tens of thousands or millions or more of light years away. Traveling at the speed of light, it would take you thousands of years to get there. It's kind of impossible to imagine. They're mostly very, very dim, especially in today's light polluted skies. So they require significant imaging time. So when I got into astrophotography, this was the object I most wanted to capture ever since I was a little kid. This is called the Andromeda Galaxy, or M31. And it's our neighboring galaxy. And in our local group, we have a local group of several galaxies. The main ones are Andromeda and the Milky Way. And this is a staggering 2.5 million light years away. So this is what the Andromeda Galaxy looked like 2.5 million years ago. Never mind looking at what Abraham saw, it would have looked exactly the same because that light is still 2.5 light years away. So minus 5,000. So this is about 15 hours worth of data, as opposed to a very short period of time for a planet or the moon, which might be a 0.001 second image. And all these red areas are nebulae in the Andromeda Galaxy, 2.5 million light years away. This is the satellite galaxy of Andromeda. So that's another little galaxy that actually orbits the main galaxy. it's also a staggering 220,000 light years across, meaning traveling at the speed of light, it would take you 220,000 years to get from one end of the galaxy to another. And just so that you can put this into perspective, this is a huge target in the sky. So in the bottom right here is the moon, and the Andromeda Galaxy fills up my entire frame. When I photograph the moon, this is how big the moon is. So the ancients actually would see the great Andromeda Galaxy as a big, bright, oval smear, several moon diameters wide. They would have seen this, not this detail, of course, but it's visible in dark skies. It's pretty incredible. And so if Abraham was looking at the sky, they would have seen something here that they thought was a nebula. Of course, they didn't know what that was until very, very recently, just about 150 years ago. This is the second most photographed object in the night sky other than the moon. And this is the Great Orion Nebula, M42. And it's about 1,500 light years away. Again, this is a very, very, very big target that is also visible to the naked eye, Rabbi Mike. And this is visible just below the sword below the belt of Orion. There's a sort of a greenish purple area there that even in light polluted skies, you can kind of see. And in the time of Abraham, they would have seen something very distinct there. And of course, they recognize the Orion constellation. It is absolutely one of the most recognizable constellations of all. And so this is just a few fingers width below Orion's belt. This center here, this is called Trapezium, and is the closest stellar nursery to the Earth. And that's about 1,500 light years away. And what that means is that there is intense star formation happening right there. These are bright, young white stars. And this was called the cosmic fire of creation, even by the Maya. So they knew something was very special about this object.
Hey, Michael, a question from John, who says, the colorations, like the red nebula and blue around the edges of the Andromeda, if you got, with the naked eye, would it look like that as well? If you got close enough?
If you're in dark skies, you would probably be able to see it, and looking through a telescope. You're not looking at it visually because it's too faint. You know, the problem is it's just not quite bright enough to make out detail. Looking at through a telescope or binoculars, you don't need fancy telescope. You need binoculars in a dark sky. You can start to make out some details there, and you start to see some colors. The red, by the way, is hydrogen. The blue is mainly oxygen.
Okay.
And so most of the images that I'm taking are using a light pollution filter that blocks out light of all wavelengths except for basically hydrogen and oxygen, and a little bit of some other things too, but because light pollution is in different wavelengths from those things, which is good. And the nebulae are basically hydrogen, oxygen, and sulfur a little bit as well.
Sure.
And so you block out all the other light, the extraneous light, and you're left with what it really looks like.
Got it. Michael, his question was actually not from here, but if we were closer, would it still appear red or blue? So if
yeah, I think so, because the red, so hydrogen is basically in the red end of the light spectrum, and oxygen is sort of in the blue. And so if you had no other light pollution around you and you could just kind of see it, it would look very red. I think it would. Yeah. And you know, the problem is that we just can't see the others. We can't see, it's too faint. You know, but if you're out in space, my guess is it would look pretty red. So it's a great question. And if you're in really dark skies, you can shoot without filters. So you're just shooting with a color camera and you get a true color image and it's red. Yeah. So that's very accurate.
Another Gary wants to ask if anybody else can see the face in that picture. He saw a face in it.
That's right. And so I think to me it looks like a dog, you know, and you know, here's the eyes, and you know, I kind of imagine this is like the Saint Bernard with like the barrel down here, and there's, you know, its nose and stuff. This little guy down here is called the running man. If you look at it closely, you can see a little guy running through there. And what you'll find is that all of the targets are named after something they look like, if you use a little bit of imagination, kind of like you're looking at clouds. And sometimes it looks really like that thing. And in many cases, it looks like something else completely, and they just misnamed it. So, and we'll see one of those really soon too. So the next target is probably one of my favorite of all, and this is called the Horsehead Nebula. It's also in Orion, and if you look at Orion's belt in the constellation, the bottom star of Orion's belt on the left-hand side is right here, which is called Alnitak. It's extremely bright, and all this stuff is sitting right there, and it's crazy. There's this blue nebula, this other nebula, this is called the Flame Nebula, and what you can't see is that the Orion Nebula, which is on the previous image, is just off the screen to the right, just to the right, and that's where that's how close those are in space. Of course, one of the most famous targets of all is this, the Horsehead, which looks like a knight from a chess game. And it's about 1,500 light years away, just like the Orion Nebula. So most of you will probably be able to name this. Mike, can you name this target?
Would that be the belt?
This is
Orion's belt.
This is the Seven Sisters, the Pleiades.
Oh, Pleiades, of course.
And
Like,
this is one of the most famous and recognizable targets out there, and has been recognized from the ancients' time in every civilization. Basically, every civilization that looked at the stars has some reference to this. And I forget, Mike, what the name was, the Hebrew name for what they think for the Pleiades. But there was a name for that. And it would look to them like 7 bright stars. It's an open star cluster, about 440 light years away, with many stars in it, 7 bright stars, but one of those, apparently 7 is actually 2 right here. So there's actually another one. And with blue around it. In this case, blue is not oxygen, but the blue is reflecting light in these dust clouds. So these dust clouds here are these like brown dust clouds reflecting blue light. And that's what creates an intense blue that we see in images of the Pleiades. Sorry, did you find that, Mike?
yeah, it's Hema is what it's referred to. So
yeah,
why that? But
very, very recognizable. And in fact, a little bit of trivia is that the Japanese car company Subaru has the Pleiades as its logo. And that was named because they had, I believe, the coming together of 5 or 6 companies together to form one. And they felt that was like the Pleiades. That was reminiscent of the Pleiades. So that's Subaru is the name for Pleiades in Japanese. So this is one of these targets that I think is misnamed. This is called the Crab Nebula. I don't think it looks anything like a crab. I think it looks like a brain with multicolored dye in it. But this is a really interesting target because it's fairly close, 6,500 light years away, but it didn't exist to us until 1,000 years ago, because there was created by a supernova 6,500 light years away that the light reaches only 1,000 years ago. And Chinese astronomers recognized it, and this object was so bright that it was visible during the daytime. The only other object that's not the moon that can be visible during the daytime really is Venus at certain times. So that's how bright this was, and that's again probably because we were getting the light of that supernova, which is one of the most powerful things in the universe, of course. And it created this, the Crab Nebula, an incredible, weird looking thing. And you have to imagine that in biblical times, they would have looked up in the sky, and there might have been occasions where things happened that they saw that they were like this, and they saw a star suddenly appear that would have been an omen to them, not knowing what was really going on. This is just one of my favorite targets. Has no biblical significance. It's just cool. And this is called M51, the Whirlpool Galaxy, 31 million light years away. Again, so this is what this looked like 31 million years ago, when mammals basically were barely around on the Earth. And this is two interacting galaxies.
I just want to point out that it's actually referred to as the mikvah in the sky, you didn't realize that was referring to the Whirlpool Galaxy, obviously. But
The mikvah in the sky.
yeah, that was very, very relevant and connected. So yes, it was there.
Hey,
Well, it's very
Michael,
appropriate, Robert.
Thank you.
Michael Raymond has a question. Do the
Sure.
satellites on other planets, like the moons around Jupiter, and do they function like the moon around the Earth? Do they rotate similar to us, or do they all have different ways that they do, and why and how?
Well, so all the moons are very different. They're huge, right? They're planetary sized in many cases, like the main Jovian moons and some of the Saturnian moons as well. The moons orbit like Ganymede, Europa, Callisto, and Io. They orbit like Jupiter very rapidly. So if you took an image tonight of where the moons are, and you kept on taking images during the night, you would see them shifting position, and tomorrow they'll be in a different position. And so that's how fast they're orbiting. You know, the moon, you know, goes around the Earth much more slowly. So, you know, it's a really interesting thing. And they're very different bodies. They're all unique. I believe that Europa and Ganymede both have subsurface liquid oceans. So there's very high likelihood there's life on those worlds. And so that'll be a whole other adventure for us in the future to see what's underneath the icy crust there. But there's a very good chance there could be life there, because they have all the right sustaining things, plus lots of heat energy coming from Jupiter, as opposed to coming from the sun in our case. Yeah, but they're all unique and amazing worlds, you know, and you can have oceans of liquid methane, for example, and you know, which is insane on Titan. So you can have an ocean that has all the same properties of an ocean here on Earth, tidal currents, erosion, you know, but it's methane instead of water. So yeah, think about that for a second. It's pretty crazy.
It's crazy.
Yeah.
Hey, Rabbi Mike, do you want to wait on Mavis's question, or you want to answer it now?
I'm gonna let Mike finish, and then we can get theological on it. Unless it's Mavis's bedtime. That's the only thing I'm worried about.
Well, we're almost there. We're almost there.
Okay.
So again, this is the Whirlpool Galaxy. Two galaxies interacting. So that's another galaxy up here, and along with the main galaxy here. And this is about 15 hours worth of data to put this all together. And again, all the red areas are nebulae in M51, like the Andromeda, like the Orion Nebula is a nebula here in the Milky Way. But we're seeing those 31 million years distant. Just, I think, a cool target. This is called the Soul Nebula. What do you think this looks like, Rabbi Mike?
Well, I think you're telling me it looks like the soul, but you know, we can't really see a soul. What does it look like?
I think it looks like a baby, like a little.
Yeah, exactly. It looks like a baby. So sometimes it's called like the fetus nebula. And you know, it's an incredibly complicated target. It's huge, beautiful, and what's always amazing to me, you know, and you can have a debate about, you know, the veracity of the Bible or the meaning of God and the universe, but you see these structures out there, and they look like this, and how did it get like that? You know, and this is not a tiny structure. This is hundreds of light years across. Like, you know, you've got hundreds of star systems or thousands of star systems in this, you know, 7,500 light years away from us. So it's just a massive, massive, massive thing. And what's cool is that right beside it is the Heart Nebula. So this is often referred to as heart and soul. So this is a mosaic of a couple of different images that I shot a couple of years ago now in wide field. So again, imagine that the moon would just be down here in this bottom right image. That's how big this is. And just a giant, giant area. So if these areas were a little bit brighter, they would fill the night sky. Like you would walk outside and see that basically staring at you, which would be crazy if the sky was just a little bit darker. This is a target I didn't shoot myself, but a friend of mine, Greg Turgeon, who has he's a dentist in Edmonton, Alberta, but he has a remote telescope in Chile, and sent me this data to process for an astrophotography processing contest, which I did not win. This is called the Pencil Nebula. It's a southern hemisphere target. We don't get it here. I just think it's ridiculously cool. All kinds of crazy stuff here. Again, the red is hydrogen, the blue is oxygen, pretty much for the most part. So that's pretty much all I've got. And this is a view of the Lobster Claw Nebula and the Bubble Nebula up here. As you can tell, I'm very passionate about this. I think it's, it's hard to get bored doing this kind of stuff.
I think naming something a lobster claw is sort of like compared to like the fetus or the heart or but lobster claw. Whoever got that rights to name that one, you're like, dude, come on, get a little more creative.
At least it kind of looks like a lobster claw though, as opposed to Crab Nebula, which looks like a brain, right? Yeah. So if any of you have questions, I'm happy to answer. I'm going to end my share.
First of all, let's just say thank you to those are remarkable photographs and lots of information packed into them. Really cool stuff. I mean, I should give a shout out to Facebook. Thanks, Mike loves to share when he captures something really cool on Facebook, and my wife and I will happen to be flipping through one night and we're like, oh, look what Mike got there. Look at that one. So you see, and so you can friend him on Facebook and say it's a sheer shalom connection, and you'll get to see the next day after he processes things what's up there too. It's cool.
Okay, Michael, you got an attaboy from Jamie. Raymond had one more question about some of the satellites. Are any of them stationary? Do any not move relative to the planet they're around?
I don't think that would be physically possible, because it has to, even the moon goes around the Earth, right? Even though it doesn't look like it changes, but it's going around the Earth. So, so all the satellites would have to move in some way, shape, or form, because everything is orbiting the sun, and our sun orbits the galaxy, by the way. So, even our own solar system is moving around the galaxy over a period of, millions of years. And so everything is going. So no, it wouldn't be static. It would be stable. It's going to be, and some of them are moving really fast. Like I said, I think that the rule of thumb is probably more that they're moving really fast around the planet that they orbit around, as opposed to not moving at all.
Lots of information packed into this. Like, it's one thing about the beauty of these and how they come to exist. Something of capturing them and the opportunity to do that, to focus on different things. Mavis asked a theological question to turn us in a little bit of a different direction, but Mavis asked if God lives on top of space or in space, and where God exists. And so to answer Mavis's question, God is everywhere. So God is both, on top and within, and here on earth and within you and within me, and all around us. And so God is really everywhere. We think of God in human terms because that's the only language we know, right? And so what we're familiar with, but it's really difficult for us to grasp God's greatness in a sense too. One of the great rabbis of the past 1,000 years, Rabbi Moshe ben Maimon, Maimonides, says that God is the supreme intellect, and we humans can only understand so much. The more we understand of our world, science, he was a physician, the more we understand it in our world, the more we're closer to God we become. And the one mind, human, that became so close to God that he actually could, connect with God different was Moses, the greatest mind of all. The more we know, the more we can understand of God, but we only can get so high, only can get so much knowledge because we're still human, right? We're limited in that capacity, unless you're Gary Schumann.
I have my limits.
Yeah, that's what Stacy says.
Okay, you want to talk theology, or is that it for you?
I just wanted to give Mavis a shout out and answer that good question she had, because I think it's really, really good. But we're at an hour and 10 minutes right now, so in deference to people's time and stuff too. And I see, some of our people are dropping off now and thanking Dr. Shapiro for his elucidation of the stars and helping us understand that. So I really appreciate your time, both of you, Gary Schumann and Dr. Michael Shapiro, and Audrey Bloomberg behind the scenes, managing things for us and helping it work well. Thank you, Audrey, for from our team at Temple, helping make all this work. We have some more things that will be coming up on the calendar. Most importantly, and most excitedly, are things that we'll be able to do in person. June 4th, we will have services outside in person. We need you to RSVP for those. You can do it through our website. We had services in person for confirmation Sunday night. Dr. Shapiro's son became a confirmand for Shavuos, and we had 100 people there. On Friday night, we had our high school graduation with 16 high school graduates and had 100. It's great being together. We want to, build upon that and do more of that. And so starting June 4th, throughout the whole summer, Friday night services outside in person. So we're looking forward to that. For those who can't make it or aren't as comfortable yet, all of our services will be broadcast online as well. And so thank you. Audrey has dropped in the RSVP link for that too, for June 4th services. You have to RSVP for each week as well. Secondly, our Hot Topics class last Tuesday night had to be canceled or postponed. And it's what's Jewish about Black Lives Matter. Is a Jewish topic, and Rabbi Daniel will be rescheduling that. We don't have a date exactly yet, but watch your calendars or your emails for that too. Yeah, good stuff. Going to glide into the summer and enjoy nights outside and fun things like that. And we'll have a little bit less programming at Temple during these summer months, and we're excited for that. And we're gearing up for Gary Schumann's daughter's wedding, so we have to really, give ourselves the time for that too.
We are, hopefully, with fingers crossed. I'll get one married off.
Yes. Mike, any parting words to send us off tonight?
It was a pleasure talking tonight. It was lots of fun. And, for those of you, you can, if you're on Instagram, you can follow me at AstroShap, or on Facebook, of course. And someone asked if I sell my photos. Not really, but if you're interested in something, let me know. And I'm sure we can work something out. And we can. I think my email is on there, but feel free to email me at mrshapiro@hotmail.com. So, but it was lots of fun tonight. Thanks again.
Thank you, everybody.
Thanks all.
Thanks, everyone.